Hi guys, welcome to exponential growth and decay. What we're going to do is we're going to compare and contrast exponential growth to exponential decay in a variety of situations like equations, graphs, and tables. So let's get started. Exponential growth. Now what is growth? Growth means something is getting bigger or increasing, so that you can kind of think of that. And with exponential growth, we have an equation for him. Y equals a times b to the x. A is the initial value, b is the base, and he's always going to be bigger than 1 because he's growing. So any number bigger than 1 because he's growing, and x is just the exponent. So, real world example or word problem of exponential growth. You deposit $4,500. So I'm going to start with, I have $4,500. That's my initial amount. That's how much I start with. That's going to be my A. In an account that pays 5% interest compounded annually. So that pays compounded interest. This means that it's growing. So it's growing 5%. So it's increasing at 5%. Write an exponential function to model this. So I'm going to start with writing my exponential function. Well, we know it's y equals a times b to the x. And I already know a little bit of information. I know a is 4,500. And b, now that's where it gets a little bit interesting. So we know that b is greater than 1. And we change this to a decimal. That's 0.05, because that's what you move it over 2 spaces to make 0.05 as a decimal. That's definitely not bigger than 1. But since it's growing, you have to do b is 1 plus your rate, which is 1.05. I hope that made a little bit of sense to you. Whatever your percent is, you're going to add 1 to it after you change it to a decimal, and then you'll have your equation. So y equals your initial amount, change your percent to a decimal, add 1 to it because it's growing, and then to the x power. So 4,500 times 1.05 to the x is your equation. Now, what if you were given just a table and it says write the rule? Now, this is kind of going back to what you learned back in Algebra 1. I'm going to look for the y-intercept. That's when x is 0. See, 0, 2. This is the initial amount. This is A. Isn't that a nice? Anytime you see 0 in the x's, look for the y-intercept. That's when 0 is the x. That's what your initial amount is. Now, I'm going to pick any 2 numbers I want to on here. So I'm going to pick something simple. I'm going to pick 32 and 8. And I'm going to say 32 divided by 8 is, so I'm just going to divide. 32 divided by 8 is 4. That is going to tell me the growth rate. That was pretty interesting. And I could check it and see. Is 8 divided by 2 4? Yes, it is. Is 2 divided by a half 4? Yeah, really it is. Is a half divided by an eighth 4? Yeah. Or I could have said an eighth times what is a half? 4. A half times what is 2? 4. 2 times what is 8? 4. 8 times what is 32? So again, how did I find the growth rate? Since I'm talking about growth and I notice these numbers down here are getting bigger. Start with fractions and they keep getting bigger numbers. That's how I know this is growth. Bigger numbers. I take one of them divided by the one in front of it, and that gives me the growth rate. Now, to write my equation, which was y equals a times b to the x. So y equals a is 2. And b over here we found to be 4. there's my equation. I put my initial value in there. That's how much it's starting at, times b to the x. Now, what if you were given a graph? So here's a graph. Isn't he beautiful? He's J-shaped. So we know he's exponential, and he's going up, so we know he's growth. He's increasing, so we know he's growth. Remember, that's how we know these things. So just like the last problem, I'm going to find the y-intercept. Well, this is the y-axis right here. So that means the y-intercept is right there at 5. So A is 5. And I'm still going to do like I did a moment ago, and I'm going to divide two of my values by each other. Well, this one looks like he's at 10. This one looks like he's at 20. So I'm going to take 20 divided by 10, because it's the last one, divided by the one in front of it. 20 divided by 10 is 2. So these are doubling. Doubling is what times 2 means. And you can kind of see, is that true? Kind of checking it out. If this is doubled, so 5 times 2 is 10. 10 times 2 is 20. Yeah, that seems to be looking pretty good. So now we're going to write our equation. It's y equals a times b to the x. So y equals a, which is 5. That's the y-intercept. B, which is 2. And that's what he's doing. 5 times 2 to the x. Isn't that amazing? Pretty easy, right? Now, you may think, well, on that word problem, you had to add 1 to the decimal, and the decimal was a percent. I haven't used any percents in any of the tables or the graphs, so we are good right now. And these numbers, all these b's, have been bigger than 1, so we know that they are growth. Now, decay. Decay, if you think anything about it from science, that means something is rotting or going down, decay. So our graphs are J's, but they're going to be J's that are going to be going the opposite direction. They're going to be going down. That's what decay is going to look like. So we have the same equation, a times b to the x, where a is the initial value, x is the exponent, but b is a number between 0 and 1. So he's a decimal or a fraction. And he's between 0 and 1. That's how we know he's decreasing. He's going down. Now, we call it a growth rate still. You'll hear some people call it a decay rate. I like the word decay rate because it means it's going down. But a lot of people still use the word growth rate. So I just want you to know that if it's a decimal between 0 and 1, it means it's decaying or going down. Let's look at a word problem. We have a car. It was purchased for 18 grand. Okay, that was our initial amount. The car depreciates. It means it goes down. Depreciates means it loses value by 20% each year. So it's going down by 20% each year. That's decay. Write an exponential function for this scenario. Well, remember, this one's a percent, so I'm going to take 20%, change it to a decimal, so that's 0.20. And 0.20 is in between 0 and 1. He's a decimal. He's small. So I'm going to go to, he is between 0 and 1. Now, since he's going down, he's starting at 100% and going down. Instead of adding him to 1, we subtract him from 1. It gives us 0.8. That's important to know. When we have a decimal, if it's growth, we change it to a percent in its growth, we change it to a decimal, add it to 1. If it's decay, change it from a percent to a decimal and subtract it from 1. Now let's go to our equation. Y equals a times b to the x. The initial amount was 18 grand. The b ends up being 0.8. Now, 0.8 is also less than 1. So a lot of people will be like, well, couldn't we have used 0.2? Well, no, 0.2 is how much he's going down each year. Just like the 0.05 was how much he was going up before. So we have to adjust it with the 1. But there he is. Isn't it beautiful? All right, now what if we were given a table? Well, just like before, look for the y-intercept. That's when x is 0. So A, in this case, the initial amount is 9. And I'm going to do the same thing I did earlier. I'm going to pick 2 numbers, and I'm going to divide them by each other. Well, let's just pick 2 that are easy numbers. How about 3 and 9? 3 divided by 9, that reduces to 1/3. So that's my B. That's how much he's going each time and changing by is 1/3. So y equals A times b to the x. Y equals, my initial amount is 9. My b is 1/3. And he can be, remember, a decimal or a fraction as long as he's between 0 and 1. And that's him. Pretty snazzy. Again, if we're given a graph for decay, see how he's going down, he's decreasing, we know he's decay, but we start him the same way. We look for the y-intercept, that's on the y-axis. It's right here. That means A is 4. And then we choose 2 numbers. This one looks like he's at 16. This one looks like he's at 8. 16 divided by 8 is 2. Oh, I'm sorry, I went backwards. That's why it didn't look right. Sorry about that. I'm going to still choose those. I just put them backwards. Remember, this one is the second number, and that's the first number. So second number is 8 divided by 16. Reduce that, you get a half. Sorry about that, guys. I was not in my mind there. All right. So y equals A times b to the x. Y equals, A is the y-intercept, the initial amount. B is our amount that we're decreasing, in this case a half, and then to the x. Now, you notice how I kind of noticed that I got a number of 2. 2's bigger than 1. I was like, wait, that doesn't make sense. It's because I knew I did it backwards. So if you do that also and you make a mistake, it's okay. You saw how I was able to erase it and find my mistake. All I did is I didn't do the second one divided by the first one. So the right one divided by the left one. So, you know, if you get a number bigger than 1 and you're going down, you should be getting a fraction or a decimal. Just go back and check to make sure you divided it correctly. It's okay. No big deal. All right, now, here's what your homework's going to look like. Well, not homework, but your classwork, because I only gave you like 4 problems. You're going to create an exponential model, table, and graph, and then you're going to answer the question. So an adult here takes 400 milligrams of ibuprofen. That's A, that's the initial amount. Each hour, the amount of ibuprofen in a person's system decreases. That means a decay. By about 29%. Okay, so 29%. I'm going to change that to a decimal. That's 0.29. And then to get B, it's 1 minus 0.29. That's 0.71 equals B. And then it says, how much is left after 6 hours? Well, we'll do that in a little bit. First thing we're going to do is we're going to write our equation, because we know how to do that. So y equals the initial amount times our growth rate, our b, which is 0.71, to the x. Okay, now that's the exponential model. We did that. Now we need to get a table and a graph and answer the question. So I'm going to go ahead and go get a table. I'm going to go to Desmos to do that. So hold on, here we go to Desmos. Graphing calculator. And I'm going to type in y equals 400. And then there's 0.71 in the parentheses. Well, didn't type fast enough there. And then to the x. There he is. Well, I see nothing on this lovely picture, so I'm going to kind of zoom him around. Oh, there he is. Oh, isn't he beautiful? And look, he's going down like we thought. He's decaying. Oh, he's beautiful. Now, that graph, I would go and snag him up. You can actually go on him and, let's see, at, say we want to know what, let's see, 8, 6, this is 6 hours. Let me go up a little higher. We'll find where 6 intersects. See there, you can see where 6 is. Ride that curve until you get exactly 6. At 6, he's around 51 milligrams. It's kind of hard to see him, but you can do that. So you can ride that, but let's go to get a table because that's going to be so much easier to see. So you go to the little gear in the table, and we can type him in. We can say at here, at instead of 0, or at -2, let's say at 0 hours, he had 400 milligrams. We know that. That's how much he started with. At 1 hour, he had about 284 milligrams. At 2 hours, he had 201 milligrams. At 3 hours, 143. At 4 hours, 101. 5 hours, 72 something milligrams. 6 hours, 51.24. Oh, looky right there. That's him. 6 is 51.24. And that's what our question was anyway. So you can actually get this graph and this table from Desmos. And all you do is just write this table down and sketch this graph. Okay, so I'm going to go back to our questions. Okay. Oops. Now, a reason why I went to this one, even though it says answer, is because I actually did go in, and this is my graph from Desmos. I actually cut the table right there, and this is where we left off. This was our equation that we said. And then when he says after 6 hours, see that x? I replaced it with 6. So 400 times 0.71 to the 6th is the answer of 51.24 milligrams, which is also what we could have told here and at that point right there on our Desmos. So you can get your answers and use Desmos to help you. First thing you have to do, though, is write the equation so you know what to type into Desmos. Notice I didn't put the 6 in Desmos. I put the x. So leave it like that until you get the graph. Leave it as an x. Get you a nice table. And then go back and answer the question. That's usually going to be what goes in for x. All right, so guys, now you get to practice this on some 4 problems in class. You're going to have some exponential growth and decay problems mixed up, so you have to know which one is which. Remember, if you're given a percent, change it to a decimal and either add or subtract it from 1, depending on if it's growth or decay. And make sure you get a table and make sure you put a graph to go with it. And you can copy those from Desmos, like I did. I literally made a picture or a screenshot of each of these and stuck them in, inserted them into this PowerPoint. You can do the same exact thing on your homework. That works for me. Or you can graph them by hand, plotting the dots. Make sure you connect the dots with a J-shaped curve.